Hey everyone, today we're doing 6.2-2 trigonometric functions continued on. And so we're looking at those coterminal angles and reference angles again. And the important thing to remember with coterminal angles is the difference between them is 360 degrees or 2 pi, because 360 degrees in radians is 2 pi. So we're just going to draw up a couple examples here. And so I'm just going to use the angle of 45 degrees. And then if I want the next coterminal angle, I'm going to add 360. So I'm going to say 45 plus 360. And that equals 405. So on this second graph, I'm going to graph 405 degrees. But as we know, 45 can also be written as pi over 4 for radians. So here's when we would add our 2 pi. 2 pi can also be written as 8 pi over 4. Because then we will have a common denominator and we can add. So pi over 4 plus 8 pi over 4 equals 9 pi over 4. So 405 degrees is 9 pi over 4 in radians. So to go to our next coterminal angle, again, we're going to add 360 degrees. Or 2 pi, so we'll take 405, I'll do this lower, 405 plus 360, and that gives us 765, and then we'll take 9 pi over 4, and add 8 pi over 4 again. 8 pi over 4 is 2 pi. And we get that this equals 17 pi over 4. Now drawing it, we're going to draw that angle. And then we're going once around, and then around again. Alright. Next, we're going to look at reference angles. And so the reference angle is just from where your angle lies to the axis, the x-axis. So let's look at 45. From the angle to the x-axis, that's 45 degrees. Now if I look at, let's say, right here, and that would be 90 plus 45. We'll say this is 135 degrees. And so I want to know what is, and it's to the closest x-axis. So what is my angle from the line to the closest x-axis? So we know that halfway around is 180 degrees. So 180 minus 135 is 45 degrees. So our coterminal angle here is 45 degrees. Our reference angle. Okay, let's look at the angle 225. So this is 225. Again, we're going to look from the line to our closest x-axis. So here to here. So between 180 and 225, how much degrees is that? And that's 45 degrees. Next, let's look at the angle 315. So 315 degrees. We want to look at from the line to the closest x-axis. So from the line to the closest x-axis. So the closest x-axis would be all the way around, which is 360 degrees. So what's the difference between 360 and 315? And that's 45 degrees. So on each of these, our reference angle would be 45 degrees. Okay. Next, we're going to look at how to find the exact value. And so the first example we're looking at is cosine 7 pi. In 7 pi, you have to keep going around the unit circle. So we want to try and find that coterminal angle and go back to between 0 and 2 pi, because that's our unit circle. And we can look at our unit circle to get our answer. So here, I'm going to say we are above 2 pi. So we need to subtract, and we're in radians, so we need to subtract 2 pi to start getting in between our 0 to 2 pi zone, which is our unit circle. So 7 pi minus 2 pi, that's our difference between the coterminal angle, and that equals 5 pi. That's still bigger than between 0 and 2 pi. So we need to subtract another 2 pi. So 5 pi minus 2 pi equals 3 pi. That's still bigger. So we need to do it again. So 3 pi minus 2 pi equals pi. Pi is between 0 and 2 pi, and that's on our unit circle. So now we can just say, what is the cosine of pi? And looking at our unit circle, the cosine of pi equals -1. Okay, so now we're going to look at 7 pi over 2. So we're going to subtract 2 pi. So 7 pi over 2 is bigger than 2 pi, because if we had a common denominator, 2 pi with a denominator of 2 would be 4 pi over 2 here, equals 2 pi. So we need to subtract our 2 pi because 7 pi over 2 is bigger. So we're going to subtract 2 pi, or 4 pi over 2, so we have that common denominator, and we get 3 pi over 2. This is less than 2 pi, but it's still bigger than 0. So this is on our unit circle. So we're going to look for the cotangent of 3 pi over 2. And then we can remember that cotangent is cosine over sine, which equals cosine over sine. So cosine of 3 pi over 2 divided by the sine of 3 pi over 2. The cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is -1, and that equals 0. So the cotangent of 7 pi over 2, or the cotangent of 3 pi over 2, is 0. All right, next we have the sine of -225 degrees. This is less than 0. Negative is less than 0, so we need to now add 360 so we can get into that range of between 0 and 2 pi. So 225 plus 360, and that gives us 135 degrees. And that's between 0 and 2 pi. And remember, 2 pi is 360 degrees. So 135 is between 0 and 2 pi. And so now we just need to figure out what is the sine of 135 degrees. And if we go look at our unit circle, that equals √2 over 2. Okay, so next we're going to find the exact value of the 6 trigonometric functions of 390 degrees. Okay, so first we got to check, is 390 degrees between 0 and 2 pi, or 0 and 360? 390 is above, so we need to subtract 360 degrees to get our coterminal angle, and that equals 30 degrees. So we're going to go find those 6 trigonometric functions using our unit circle. So the sine of 30 is 1/2. The cosine of 30 is root 3 over 2. The tangent of 30 is root 3 over 3. The cosecant is 2. The secant is 2 root 3 over 3. And then cotangent equals square root 3. Next, we're going to use our calculator to approximate and round to 2 decimal places. So this one we just going to plug in our calculator, but we need to do just a little bit of work first. So first, we're going to look at cotangent of 70 degrees. And on our calculator, we only have sine, cosine, and tangent functions. So cotangent is 1 over tan. And then we're going to plug in that 70 degrees. So going to our calculator, we want to make sure that we're in degrees mode because 70 degrees. And then we're going to do our 1 divided by the tangent of 70. And then that equals 0.36. All right, that's it. Next, the sine of pi over 8. Now we just have to make sure that we need to change it to radians mode on our calculator because pi over 8 is a radian. So we're just going to shift settings, degrees to radians, and then the sine. And then we're going to look for that pi symbol. I always lose it. Okay, pi divided by 8, and that equals 0.38. So this equals 0.38. Okay, next we are given a point, and we have to find the 6 trigonometric functions. So here we have a point, so we're going to draw our quadrant plane, and then we're going to go to 4, 1, 2, 3, 4 in the x direction, and then -3 in the y. So 4 in the x, and it's going to look like this in pink. So 4 in the x, 3 in the y. And then we need to connect our triangle here. We have this right triangle. So we went 4 in the x and then -3 in the y. So how do we figure out that hypotenuse? We have to go back to using Pythagorean theorem, that a squared plus b squared equals c squared. So -3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. 5 equals c. All right. So the next thing we are going to do is find all those trig functions. So sine, and then we remember using our SOHCAHTOA. Sine is opposite over hypotenuse, and our angle is right here. So opposite, your angle is always near the origin. So the opposite is -3, and the hypotenuse is 5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant, just flip sine, so 5 over -3. Secant, flip cosine, 5 over 4. Cotangent, flip tangent, 4 over -3. And that's our 6 trig functions. All right, lastly, we are told that f of theta equals sine, g of theta equals cosine, and theta is 60 degrees. So we're going to find the exact value of these, of A, B, and C. So g of theta. So we just want to know, what is g of theta? So g is cosine, and theta is 60. So what's cosine of 60? Look back on our unit circle. That equals 1/2. Then we have g of theta squared. So g of theta, we already know from part A, is cosine of 60. But then we have to square that. But from part A, we already know that cosine 60 equals 1/2. So we have 1/2 and then squared. 1/2 squared equals 1/4. And then g of 2 times theta. So g is cosine. And then 2 times theta. So 2 times 60. And 2 times 60 is 120. So again, we're going to go look at our unit circle and check, okay, what does cosine equal at 120 degrees? And cosine equals 120 degrees at -1/2. All right, please let me know if you have any questions.